Hello, today we're going to be talking a little bit about molecules. Have you heard the word molecule before? Maybe in a science class. Have you heard of oxygen or water or salt or sugar? I'm going to guess that yes, you probably have. And so if you have, these are molecules that you've interacted with. These are actually molecules that are essential for keeping us alive. Some other molecules you see here are caffeine. If you know me, you'll probably have seen me drinking my coffee in the morning or even in the afternoon to get my shot of caffeine. Another molecule we all have and depend on is this molecule serotonin that is in our brain and responsible for our mental well-being. So even if you haven't heard of molecules, molecules have been really important in your life up until now. Our job today is to understand exactly what a molecule is on a deeper level. So let's start with one of my favorite molecules, which is water. Maybe you've seen H2O, maybe you've seen an ad like this with a water bottle or even this brand H2O, which is a kind of flavored water, or even something like this one that says H2O water. A little silly because H2O of course is water, so you're essentially saying water, in the same way that when people say chai tea, you're essentially saying tea. But regardless, H2O is a common way to refer to water. What does that actually mean when we say H2O? Well, it means that each water molecule has one atom of oxygen. And so in H2O, if there's no number, there's no little subscript number after the element symbol, we can assume that that is one atom. So H2O, it doesn't have any number here after the O, so we assume that there's one atom being represented. And then this 2 indicates that there's 2 atoms of hydrogen or of H. So H2O means 2 atoms of hydrogen, 1 atom of oxygen connected by a chemical bond. So what is a molecule? A molecule is a neutral group of 2 or more atoms. They may be the same element, they may be different elements held together by chemical bonds. We have 2 examples here. We have water, like we've been talking about, H2O, the H's are connected to the O's. There's different types of chemical bonds, polar covalent being one type. And then we also have common table salt represented here, which is sodium and chlorine, or NaCl, 1 atom of Na and 1 atom of Cl. You'll notice there's no number listed after the Na or Cl, so that means we assume it's representing just 1 atom. So NaCl means 1 atom of Na, 1 atom of Cl. All right, so a really important distinction to make here is that we are now talking about bonds within a molecule. Last unit we talked about intermolecular forces, or the connections between molecules. These are the things, remember, that are breaking when you do a phase change. Now we're talking about intramolecular forces. Intra means between, intra means within, and it's inter that means between. And so now we are talking about intramolecular forces. So that's these connections that happen within a molecule. So during a phase change, of course, these intermolecular forces would be connected, but intramolecular forces would not. So H2O is held together by intramolecular forces, and then different H2O molecules might also be connected by those intermolecular forces we learned about last unit. So water and all molecules really can be represented a few different ways. You can represent several molecules with their intermolecular forces. You can represent a molecule with a ball and stick, so 1 oxygen, 2 hydrogens connected with a line here. This representation to the right is pretty similar with oxygen again and hydrogen. You can represent a molecule with just the letters that correspond with the elements. And of course, these lines referring to intramolecular forces, those connections within a molecule. You can even show the atoms and their electrons and how the electrons are interacting in a bond. So, how are bonds formed? Let's zoom in on that last picture that I mentioned with those electrons. So hopefully we're seeing here the bonds are formed by interactions with valence electrons, with the valence electrons of two different atoms. So I'm going to add here interactions between, and those interactions can vary. We'll learn more about different types of interactions, but it's important to note the bonds are formed by valence electrons. So we see here the valence electron from hydrogen interacting with valence electrons from oxygen. And so when we say a bond forms, it's actually made of valence electrons. So my next question for you is, why do molecules form, and why do particular molecules form? So for example, in water, we know there's 2 hydrogens and 1 oxygen, and why is it like that? We don't refer to water as HO or OH. The molecule that forms between oxygen and hydrogen is not 1 hydrogen and 1 oxygen atom. Similarly, it's not H3O. We don't refer to water as H3O, and water does not form H3O with 3 hydrogens and 1 oxygen. The molecule that forms, the most likely molecule to form between hydrogen and oxygen, is indeed H2O. The molecule that forms is H2O with 1 oxygen and 2 hydrogen. Why is that? Well, it actually goes back to what we were looking at with the periodic table and valence electrons. Hopefully you remember, in this first group here, there is always 1 valence electron, 1 electron in the outermost energy level. In our second group, how many valence electrons would be in group 2? 2 valence electrons. Main group 3 or group 13, you see main group 3 or group 13 has 3 valence electrons. Group 14, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. So you'll notice in water, and really with any molecule, the bond is formed by these valence electrons interacting. In water, it happens that the valence electrons get shared between the 2 atoms. What does that sharing look like? Well, it means this oxygen now has access to 1, 2, 3, 4, 5, 6 valence electrons that it had before, and then also those 2 from hydrogen. So 7 valence electrons, 8 valence electrons. So now this oxygen atom in water has 8 valence electrons because it's sharing 1 valence electron with each hydrogen. And my hydrogen now has access to 2 valence electrons. And same with this hydrogen. It also has access to 2 valence electrons. Well, these numbers should be important to you. These are the numbers of a full valence energy level. So molecules form so that each atom reaches a full valence energy level, a full outer energy level. So that can happen with water, where there's a sharing of valence electrons going on. It can also happen by a donation, like we see here. Remember, this guy is table salt, NaCl, and Na actually gives up an electron, and that electron moves all the way over to Cl here. So now Na, this valence shell, would go away because that electron is gone, and Na would now have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Chlorine, Cl, has 1, 2, 3, 4, 5, 6, 7, 8, the one that it got from Na, from sodium, and both have a full valence shell. So we see a little bit more detail here. Again, NaCl is normal table salt that you put on your food, and it forms by interactions of the valence electrons between Na, or sodium, and chlorine, or Cl. So this is all we're going to talk about for molecules for the moment. The next things that we're going to be learning are more specific types of intramolecular bonding. Intramolecular bonding, or connections that hold molecules together. So ionic and covalent bonding are connections that help form molecules. We'll also learn how to predict what molecules will form given two different elements. So for now, you should know what a molecule is. You should know the difference between intra and intermolecular bonding, and you should also know why a molecule forms so that each atom can reach a full valence energy level. Any questions? Make sure that you email your teacher and let them know. Thank you for listening.